Hey guys, welcome back to another A-Level Maths video. Again, this is one of those aiming for A-star maths videos. This time we're going to go through some projectiles questions, and these are just three fairly tricky projectiles questions that I've come across and that some of my students at school and in tuition have asked me to go through, and they're pretty interesting, they're pretty unique, they're different, and if you understand how to do these and understand the problem solving behind it, it does imply that you're going to get the question right in whatever exam that you end up doing in the future. Now, there is something I should say. These are not necessarily all of the hardest questions that's ever happened, but I think three questions I should be able to get it done in under 30 minutes. I'm hoping. They're 12 markers, so who knows. So it fits quite nicely in the video, but if you want like a part two where I find some of the ones where you have to like form equations and things like that, so say show that t equals and then some long algebra with trig in it, then do let me know. But before we get started, if you've ever found any of these videos useful, please do consider subscribing. It really does help me out. And my website and my email address are in the description in case you want tuition or to ask any questions or anything like that. But let's get on with this first question. So we have at time t equals 0, a particle is projected from a fixed point O on the ground with the speed of u at some angle theta. The particle moves freely under gravity and passes through point A at t equals 4. Now already what I would do is highlight some stuff. Now some of this information is already on the diagram, that's fair. So you can get away with not highlighting literally everything, but again, I just think it helps me because there's a lot of words, so we can try and fix that. As it passes through A, the particle is moving upwards at 20 degrees to the horizontal, with the speed of 15, as shown in the figure 3. Find the value of u and the value of theta for 7 marks, quite hefty. Now, if I'm being completely honest, and I tell my students this all the time, especially in mechanics questions or even in pure, when you have a large question like this, 7 marks, it's highly unlikely that you'll know every single step to do. For me personally, I have no idea how to start this question. Oh no, hang on. I have no idea how I'm going to solve this question. That's me being completely honest. I'm not pretending or anything like that. So what do I do? In any mechanics question, the first steps are always to resolve horizontally and vertically. In the case of projectiles, that means you're going to write equations for the horizontal motion and for the vertical motion. If you do that, generally speaking, you get an equation you can solve. So the first thing I need to do is I'm going to take a direction as positive, I'm going to take to the right as positive and upwards as positive. And I like to start with horizontal because horizontal tends to be quite short, quite quick. The reason for that is there's never any acceleration. So what does that mean? Well, it means that with my variables, the starting velocity should be equal to the final velocity because there's no acceleration, right? That means the velocity doesn't change. So I can write that the initial horizontal velocity, which if I break this down, so we have u going up and to the right like this, there's theta here. I want the adjacent component because the adjacent is heading horizontally. That would be u cos theta because again it's adjacent, cos is for adjacent. And for this one up here, again we can draw, if you want you can draw a shallower line, although it doesn't really make a difference. This is just to help us with the trig. We have 20 degrees and 15. Then we're going to have 15 cos 20. Those two values should be equal because again there's no horizontal acceleration. So the starting velocity should be equal to the final velocity. So I'm just going to write u cos theta equals 15 cos 20. Now in most questions you would actually use the speed equals distance over time or distance equals speed times time. So this is the most common equation that you'll use. Distance equals speed times time. The reason why I haven't used that in this case is because I have no distances. So why would I write distance is speed times time? There's no point, right? If you want, you could still write it. That's totally fine. Then you'd have d is equal to 15 cos 20 t. That's just another thing that you have. Now vertically, that's where we have something a little more interesting. We're going to write out SUVAT because we do have an acceleration. Remember with SUVAT, you have to have some kind of acceleration to do it. If acceleration is 0, most of the equations break down. So S, don't know, but I also don't care. U is going to be u sine theta because now we want the opposite component of this triangle. The final velocity is going to be 15 sine 20, right? Acceleration is minus 9.8. Why is it minus? Because I'm taking upwards as positive and acceleration is always downwards when it comes to gravity. And lastly, but certainly not least, time. Now we do know time. Time is 4. Which means we do actually know the horizontal distance, by the way. Because speed times time, we'd have 15 cos 20 times 4. But fair enough. And what we're trying to work out, that's a really good question. Well, we're trying to work out u and theta. So the only variables I care about are u, because u is what I want. And then we have the variables v, a, t. So I'm going to look for u, v, a, t, which is of course v equals u plus a, t. Let's substitute those variables in. I personally don't, actually work out 15 sine 20 till the very end, because most of the time it's a irrational number. It's a really long decimal, an infinitely long decimal if you want to be technical. So I would prefer to not do that. Simple as. Then minus 9.8 times 4. You know what? Just to be safe, let's just use a calculator. 9.8 times 4 gives me 39.2. So minus 39.2. Now, this is interesting because I have an equation here and I have an equation here. Now, solving this is a simultaneous equation. So what you could do is rearrange for u here and substitute in and do all some kind of crazy stuff. That's quite long. Instead, I'm going to show you a shortcut because shortcuts are cool and I like shortcuts. Instead, we can use a trig identity to make this a lot faster. Remember, if I rearrange this for u, I'd get 15 cos 20 over cos theta. Subbing that into here, okay, it's not crazy, but it is longer than what I'm going to do. Instead, if I move the 39.2 over to the other side, so now I have u sine theta equals 15 sine 20 plus 39.2. And I'm going to call that my equation 2. If I divide equation 2 by equation 1, look what happens. Now, again, those of you that have learnt this in school already or have had decent teachers, you probably already know what's going to happen. Cos theta equals the sine stuff, so 15 sine 20 plus 39.2 over the cos stuff, which is 15 cos 20. The u's cancel out, which is ideal because that means we only have one unknown. But also, what's sine over cos? It's tan. So this is just all equal to tan theta equals all of that stuff over there. So all I need to do is do tan inverse of all of that and I'm done. Very good. So inverse tan, and let's do it. So we have 15 sine 20, close those brackets, plus 39.2 all over 15 cos 20. Let's close those brackets, close that one, and we get 72.36. Let's call it 72.4 to 3SF. That's one of our solutions, but it also wants us to work out u. I think subbing back into here would make the most sense. So u is equal to 15 cos 20 over cos theta. So u equals 15 cos 20 over cos of the answer we just got, 72 point dot 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 dot. And let's do it. So 15 cos 20, we are over cos answer. I was about to make a tragic mistake there. And we get 46.5 meters per second to 3SF. I've had questions before about how many decimal places or significant figures should you give it to. Honestly, they're fairly reasonable as long as you're reasonable. So don't give something to 1SF, right? Don't say this is 50. Instead, you want to round always to at least one decimal place. So like 3 significant figures or 1 or 2 decimal places is what I'd recommend. Again, as long as you're not being sarcastic, you should be completely fine. So yeah, that was fun, right? Very fun. So that is the hardest part about this question. After that, it's a lot easier. But for 7 marks, if you look at the actual algebra, it's not that bad, but it is a lot of work. And again, can you imagine someone telling you that they know how to do this question exactly when they first look at it? I can't imagine that personally. But instead, I resolve horizontally, vertically, and see what I can do. You will get an equation you can solve. It'll probably be simultaneous, or it'll just be a nice, straightforward equation you can solve. Other than that, it's just putting in your variables correctly, which is fun, isn't it? So, at the point B on its path, the particle's moving downwards at 20 degrees to the horizontal with speed 15. Find the time taken to go from A to B. So if I mark this point, logically, because it's going downwards, it should be after the maximum, somewhere like this. And it's going downwards at 15, 20 degrees to the horizontal. Yeah. So in other words, it's going down this way, 15. And that angle there is 20 degrees. So we can use SUVAT again. And once again, I'm going to take upwards as positive. So what's our initial? And then do all the normal stuff, right? S equals, it doesn't say we need that, so I'm not going to bother working that out. So don't know, don't care. U is now equal to, sure, U sine theta. We do technically know what that is. So 46.5 sine 72.4. The final velocity is negative because it's going downwards. And we're looking vertically, so 15 sine 20. A is negative 9.8, and T is the thing we're trying to work out. So U, V, A, and T, it's the exact same equation from before. V equals U plus AT. Equals U plus AT. So T is equal to V minus U over A. Substitute that in, and we get our answer. And again, for 2 marks, really? That kind of sucks. Fair enough. Fair. Let's do this. So V is minus 15 sine 20. Minus U, so 46.5. Sine 20. 72.4. 20. Where the hell did I get 20 from? I'm going senile. Alright, and we get an answer of 5.05 seconds. Again, that's where, 2 decimal places, fine. Again, they're quite reasonable as long as you're not taking the mick, right? Like, don't give it to 1SF. Just don't do it. It's not worth it. The particle reaches the ground at point C, find the distance O to C. Now, when it says distance, they don't mean displacement, but the good news is, because it's completely horizontal, it actually doesn't matter. So how would you do this? Well, distance horizontally is speed times time. So what we need to do is work out how long it takes to reach this point, and then times it by the horizontal velocity, which is completely fine. It's actually 15 cos 20. So that's kind of fun, isn't it? Fair enough. Anyways, so what I would do is, again, vertically, when it reaches C, its displacement vertically is 0, because it goes up. So its displacement goes up to, let's say, the max value 10 or whatever. Then it goes back down to 0. So its overall displacement vertically is 0. So S equals 0. U still equals 46.5. You know the drill by now. V, we don't... Okay, full disclosure, we do know what it is, but I'm going to put a question mark. Technically, it would be the exact same as the initial velocity, because when you throw something up, let's say with the speed of 10 meters per second, it will come back down to the same spot at 10 meters per second, just going in the other direction. But again, assuming we don't know that, because you don't need it, and T is equal to, well, what we're trying to work out. So S is UT plus half AT squared, classic, UT half AT squared. And thank God it already equals 0, because this is going to give us a quadratic that we have to solve. And the good news is, because it already equals to 0, I don't have to do any work in rearranging. And the less work I have to do, the better. That'd be minus 4.9 t squared. Why is it 4.9? Because it's half 9.8. I've just done that so many bloody times that I now have it ingrained in my brain. You can use your calculator to solve this. That's completely legit, because the main point of the question isn't solving the equation. It's getting the variables and substituting into the right equation. So we get minus 4.9 for this. We get 46.5 sine 72.4. And we get 0. So one of our answers should be 0, but we get 9.05 seconds. The other one is definitely going to be 0. How do I know? If you factorize out a t, I didn't actually put a t here. That's very naughty of me. If you factorize out a t, you're going to get t equals 0, as stated. So what's the time? The time is 9.05. So the distance now is the equation I originally had. It's u cos theta, so it's 46.5 cos 72.4. cos 72.4 times 9.05. Don't you love projectile motion questions? How long has this taken us so far? 15 minutes. Crazy. All right. We're going to do 46.5. There we are. Jesus. There we are. 72.4 multiplied by 9.05, and that's it. 127.2 meters. Now, there's something I'm going to quickly tell you about other questions. Now, in a lot of questions, you might have, the projectile being from the top of this, and then it lands over here, and they say, what's the distance? The distance is not the horizontal or the vertical displacement. It is the straight line distance. So from there, you'd work out the vertical displacement. I had no idea I could do that. And the horizontal displacement, and use Pythagoras. In this case, I'm sure I can use Pythagoras, but because the vertical displacement is 0, I get, 127.2 squared plus 0 squared, all square rooted. So do be careful when they talk about distance, they're talking about the actual straight line distance, not vertical or horizontal. In this case, the straight line distance is just all horizontal though. But let's move on to question number 2. Okay, so question number 2. I promise you this one's a lot shorter, even by one whole mark, so a whole minute. Crazy, right? No, I'm kidding. This question actually, the maths is a lot, not easier, but it's quicker, simpler, less complicated, something, I don't know. One of these words. The one I've got after this though, that's that's a fun one, trust me. But with this one, well, let's have a look, right? Points A and B lie 40 meters apart. Again, all of this information is actually kindly given to us on a diagram. So the exam boards aren't trying to, torture us that much. And the projected core and speed of 30 meters per second at 60 degrees. Wow, my hand is shaky. And B has a speed of Q at an angle theta as shown. And at time t equals 2, they collide. How interesting, right? How cool and interesting. And for part A, obviously, just find the two unknowns. How lovely. And remember, what was my step again? What was my question? It was, all you need to do is horizontal and vertical projection, right? Don't even think. Just do it. This works for every single problem in your life. Always break things down horizontally and vertically, and I promise you it'll make more sense. Now, horizontally, remember, we use distance equals speed times time. By the way, like with the letters that I chose for these, I'm sorry, I've had arguments with my students. We decided that I'll just write out the words, like literally distance equals speed times time, but, I just can't be bothered. But yeah, distance is speed times time. If we do this for particle P, we actually do know some stuff already, because we already know the velocity, and we know at time t equals 2, they collide. So let's do that first. We can do this for Q as well, by the way. So we can also write this down for Q. Because remember, we have 2 particles now, which means we can resolve in 4 different ways. How exciting, right? Horizontally for P and Q, vertically for P and Q. So that's going to be distance equals speed. Again, that's the adjacent component, so 30 cos 60 times 2. Don't know why that took me a second to read. Cos 60 is a half. Yep. Okay. So 30 cos 60 times 2 should just give me... What am I doing? 30 meters. Okay. Now, what can we say from that? Well, what I can say from that is, given that this is 30 meters horizontally when they collide, that means they collide somewhere over here. Which means I actually immediately know the distance Q has travelled. If from here to here is 30 meters, then from here to here has to be 10 meters. So we can actually say that the distance here is 10. The speed is Q cos theta, and the time is 2. So we know Q cos theta is equal to 5. There you go. We know some information now. How wonderful. And what should we do next? It probably makes sense to also do the vertical components as well, and that way we can get some kind of other information. So vertically, let's have a look. Now, unfortunately, I won't be able to write them next to each other because there's more letters, basically. So we have S equals don't know, but I'm kind of thinking about something here. u is equal to, oh, I probably should say, let's take upwards as positive. And yeah, u is equal to 30 sine 60, which is not a very nice number, but that's okay. V is equal to, now again, depending on what I'm going to do here, and I've got an idea of what I'm going to do, I'm going to leave it blank for now. A is equal to minus 9.8, and we know that they collide after 2 seconds. So given that I have 3 variables, I can actually work out any of the other 2. So what am I going to do? What I think would help is if I work out V, that doesn't really give me any information about Q. However, if I work out the vertical displacement, bearing in mind I know the horizontal displacement, if I know the vertical displacement, then I know at the exact same time, Q will also have that vertical displacement. Because they collide, right? The only way you can collide is if you travel the same to the same position, right? 2 things have to be in the same position to hit each other. So if Q was lower than P, then they would just miss. They'd go over each other. So in other words, P and Q have the same vertical displacement. So I'm going to work out S. Using that, I'm going to say that S, whatever my S is over here, is the same for Q. Simultaneous equation, job done, life is good. Remember when I said this question was short? I think I lied. I think I've just lied to you. But we have S equals, so we have S, U, A, and T. So UT plus half AT squared. Again, a classic equation. AT squared. So let's sub in our values. Where's my calculator? There's my calculator. So U is 30 sine 60. And I wonder if I can type sine. Can I do that on my keyboard and that would actually work? Maybe. Times T, which is 2. Plus a half, so 0.5. A is negative 9.8. There we go. Times 2. AT squared. Let me just check. All good. Good in the hood. I get 32.4 meters. Now, I will use the exact value. Now, if I do vertical for Q, S is going to be the exact same value, 32.4. But remember, I'm using the answer button on my calculator. My initial velocity is Q sine theta. And I have Q cos theta over there. So you're on my wavelength. You understand what I'm trying to do? V is I don't know and I don't really care. A is minus 9.8. And T, once again, is equal to 2. So S is UT plus half AT squared. Okay. 2.4 equals 2Q sine theta. And that would just be minus 9.8, right? Because a half... No, it won't. It'd be double that. 9.8 doubled would be 20.6? 19.6. So it'd be minus 19.6. So if I add it over and then divide it by 2. Alright, so this is what I'm going to do overall, right? Equals Q sine theta. And then we're going to do the exact same trick we did before. Where we're going to say that this is equation 1, the other one's equation 2. We're going to divide to find theta and then sub it back in to find Q. How wonderful. Is there any way I can do this while keeping the exact value? Kinda. Answer plus 19.6 over 2. God, man, why am I missing buttons? Oh, 15. Ah, praise the Lord. 15 root 3. And all I need to do is move this down. Now again, we're going to do 2 divided by 1. I'm going to write it in red now. I'm going to put a colon. So Q sine theta over Q cos theta equals 15 root 3. And I believe the other answer was 5, wasn't it? It was indeed. So we get 3 root 3. Oh, how nice, right? We get tan theta equals 3 root 3. Why do I feel like I know what that value is? You know what? I'm not that guy. Let's not pretend that I'm that guy. Yeah, that's not what I was thinking it was. So 79.1 degrees. And then sub it into probably the first equation here. So 5 equals So Q is equal to 5 over cos 79.1. All I've done there is I've just rearranged for Q. So 5 divided by cos answer is what we're going to do. 5 divided by cos, answer button, 26.5 meters per second. And that's my final answer. Okay. So this is a very similar question to the distance question. Find the speed of P at the instant before it collides with Q. So all we need to do is work out the horizontal speed and the vertical speed of P right before it hits Q. And can I do that? Yes. So if I work out V from this equation here, I actually can work out the speed. The speed I've already done is 30 cos 60 horizontally. So I already know horizontally it's 30 cos 60, because don't forget the speed won't change because there's no horizontal acceleration. And if I work out V from here, job is done. So V equals U plus AT. Yeah, keep it simple, right? Shall I use a different colour again? Let's use black. Black is cool, right? U plus AT. So V equals 30 sine 60. Why am I writing this out? You guys know what I'm doing. I don't know. Right. This for 5 marks is kind of crazy. We've actually done all of the work already. So this is going to be really short, which is nice. I like that. I like not having to do extra work. Very fun. I get 6.38. So the vertical velocity is 6.38. The horizontal is 30 cos 60, which is 15. So we're going to just draw a triangle. The horizontal is 15. The vertical is 6.38. And we want the speed. The speed is just the magnitude of the vector, right? Now, the vector has components 15 and 6.38. So all we're going to do is do speed. And we're going to do square root answer squared plus 15 squared all square rooted. I get 16.3 meters per second. And that brings us to the end of question number 2. Very exciting, right? Very exciting. The next question is very similar to this, by the way, just bracing you, except it's a little bit different. It's a little bit longer, I'm not going to lie to you. But that would be the final question. Again, these are some of the harder ones. There are other ones where you have to make equations and stuff, which are also hard. I'm not taking away from that. Do let me know in the comments if you want that, and I don't mind doing it. I've done a few of them. They're a bit tedious, but yeah, who knows? Who knows? Let's get on with the third one. Okay, so final question. It looks very similar to the last one. I'm actually even tempted to just give part of the answer, but no, let's do it. So we have these two particles, or 2 points, that are 50 meters apart. They get projected. You know the drill. Same kind of stuff. So 50 meters apart, and they have a speed of 20 meters per second, 38 degrees. And then we have U and theta. At time t equals 2, even the same time, P and Q collide. Until they collide, they're modelled as particles, moving freely under gravity. Find the velocity of particle P the instant before it collides with Q. Now, because they're asking for the velocity, which is a vector, you can give it as a vector, or you have to take the modulus, because they haven't said horizontal or vertical, right? Because they're talking about the overall velocity. So let's do that. Again, I'm going to start with horizontal because it's just quicker and easier, and I like my life being quick and easy. And horizontal velocity or speed, whatever you want to call it, will just be 20 cos 30, because as we've mentioned before, there's no horizontal acceleration. So that's all we have to do. I actually might leave it like that because I want the exact value. Now, vertically, this is where things get a little more interesting. Again, taking upwards positive, we have S equals, don't know, don't care, U equals 20 sine 30. V is what we're interested in. A is minus 9.8. And t is equal to 2. So v equals u plus at. Subbing in those values, let's see what we get. We get 20 sine 30 minus 2 times 9.8. Because don't forget it's going to be negative. We know it's going to be negative. Minus 48 over 5. Oh, no, minus 9.6 is nice. Let's do that. Now, the difference between finding the velocity and the speed is this. Velocity still has direction. Okay, that's one thing that we need to be very clear on. So when I work this out, I already know it's going horizontally and I know it's going downwards because of that. If I work out the modulus, all I get is the speed. I also need to work out the angle. Okay, so here horizontal is 20 cos 30 as mentioned previously. Jeez, my handwriting's awful. And it's 9.6 down. So let's say the velocity equals, and we're going to take the square root of those two things and add them together. The squares of those two things, add them together, then square root them. So we get 20 cos 30. I need to put another bracket squared plus 9.6 squared, all square rooted, 19.8. Then I need to work out the angle. That's opposite over adjacent, so that's tan. So inverse tan, opposite 9.6 over 20 cos 30. So yeah, in questions like this, it's very important to understand. If they ask for speed, then you're just working out the modulus, because that's the speed. If they want velocity, you need to work out the actual direction that it's heading in. So velocity is speed and direction. Speed is just speed. So velocity, speed, and direction. So that's, let's call it 29 degrees below the horizontal. That is exactly how you can describe this. For 6 marks, that's pretty damn good. I mean, come on, 6 marks. It's pretty juicy. I like it. Now for part B, finding theta and u. Now there are 2 facts when these things collide. The first one is that their horizontal distances should add up to 50 because they collide somewhere between A and B, right? So let's say if P travels 10 meters horizontally, then that means B has to travel 40 meters, adds to 50. If A travels 30 meters, B travels 20 meters because they add to 50. Hopefully that makes sense. So horizontal distances add up to 50 at t equals 2. So the horizontal distance for P is 20 cos 30 times 2 plus u cos theta times 2. That should equal 50. So I'm going to divide through by 2. Boom, boom, boom. And then I'm going to move this over to the other side. So we get u cos theta equals 25, because I've divided everything by 2, minus 20 cos 30. There you go. Got my first equation already. Lightning fast. Absolutely lightning fast, which has given me 2 marks straight away. Now, what about part 2? So that's the horizontal distances. What about the vertical ones? Well, we actually used this one previously. We used it in the last question. Have a think. Vertical distances should be equal. So let's do that. So now we do vertical. I'm going to go that. And I'm going to say for, what the actual thing's called? P and Q. Okay. So P, we're going to have S equals don't know, but we want to work it out. U equals 20 sine 30. V, don't care. A minus 9.8. T equals 2. So S is ut plus half at squared. Work that out. This does look very similar to the last question, doesn't it? But there are a few kind of new bits to it. That's why I've put it in here. 20 sine 30 times 2, because I might forget that, plus 0.5 minus 9.8 2 squared. 0.4. Oh my god, that's such a nice number. Right, fair enough. 0.4 meters. Am I trusting that? Why does that seem a bit small? 20 sine 30 times 2 ut half at squared is 0.4. Fair enough. And then we can do the same thing for Q. We know S should be 0.4. U should be U sine theta. And V, don't know, don't care. A minus 9.8, t equals 2. So again, we're using s is ut plus half at squared. However, in this case, we have s equals that, ut, so we have 2 u sine theta, right, because u times t, half at squared, so that'd be, well, I mean, we can type it in if we really want to. So half a minus 9.8, 2 squared, minus 19.6. Add that over to the other side, we get 20. Hey, that's nice. U sine theta, which means u sine theta equals 10. And you can already guess what I'm going to do. 2 divided by 1, you know, etc., etc. So we get tan theta equals 10 over that disgusting thing. So theta equals something. 10 over 25 minus 20 plus 30. 52.5 degrees, which is the, yeah, which is correct. Into here, we get u is equal to 10 over sine 52.5. See? Hopefully you're seeing when I added this question in, I did want to see if you guys could spot how easy it becomes once you've already done it once or twice. So if you notice, all three of these questions had a lot of similarities. A lot of similarities. I would say that the last two are very similar. Now, the reason why I put it in here is when a random new question comes up, some students look at this and they go, oh my god, I don't have to do it. But then when you show them how to do it, the next time they see something similar, it's much easier. And that really is the key thing about maths, is if you do enough different problems, enough different questions, anything that comes up is going to be a lot easier for you because you would have seen it before. So those last two questions, they are very similar, and hopefully you saw that you solve them in the exact same way, you do the exact same things, and it's just a new trick that you have. So when you see that question in another paper, you should be completely and utterly fine. Now, part C, I'm going to go through it, don't worry, although you can probably already think of a few. If you do want to see those ones where you have to rearrange a bunch of algebra and a bunch of trig in order to get something, those can be a bit weird and a bit harder, but it's mainly trig equations that you're talking about because it's a show that question. So if you're good at kind of rearranging trig and solving trig expressions and things like that, you should be totally fine. But do let me know in the comments if you want me to do it. It says state one limitation of the model other than air resistance that could affect the accuracy. There's two things you can do. One is you can actually have a look at the assumptions they've made. So their model has particles moving freely under gravity. So you can include the wind, you can include spin, you can use a more accurate value of g, you could take into account the shape of the particles. Anything along those lines will work, and that's kind of the same for all mechanics questions. Let me know if you like this style of video where I go through like 3 just of the different really hard types of questions that you can come up in any specific topic. It's like 3 really hard, I don't know, integration question styles, things like that. But hopefully you found it useful. Again, do consider subscribing if you did find it useful. Best of luck with all your revision, and I'll see you in the next one.